A salt contains only barium and one of the halide ions. A 0.1480 gram sample of the salt was dissolved in water, and an excess of sulfuric acid was added to form barium sulfate, which was filtered, dried, and weighted. Its mass was found to be 0.1660 grams. What is the formula for the barium halide? So that's what we're going to try to answer today, this question right over here. So, the first thing that we know is that the salt contains barium and one of the halide ions. So let's write out this formula. Barium symbol is Ba. Let's call the halide ion X. We know that halide ions need, such as fluorine, chlorine, bromine, and iodide, the barium ions actually need to get 2 less electrons to be stable. So they're going to have a +2 charge, barium ions, and because we're going to do the switcheroo, we're going to put the 2 down here. So that's going to be our formula for the barium halide. From there, it's going to react with what? An excess of sulfuric acid, whose formula is H2SO4. That is sulfuric acid. From here, we're going to go to barium, From there, we're going to go to barium sulfate, whose formula is barium sulfate, and that you just need to memorize. And then from there, we're going to assume that we're going to be left with our X2, because we can't forget about that, and we're also going to be left with our H2. And this looks like a balanced equation. There's a barium, there's our 2, there's our 2, and there's our SO4. So this is a good equation. The first thing we need to do here is find the moles of the product, which is the barium sulfide. What's the moles of this? If we can find the moles of this, then we'll also be able to find the moles of this. And since it's a 1-to-1 ratio, they're going to be equal. So let's go ahead and do that. So we're going to find the moles of barium sulfate. To do this, we remember that there was 0.1660 grams of barium sulfate. So we're going to do 0.1660 grams, and we're always going to write our units. And we're going to do some stoichiometry. So we want to cancel out the grams on the bottom, and we know that we want moles of barium sulfate. That's what we're trying to find. So on the top, we're going to put moles of barium sulfate. We then have to find the molar mass of barium sulfate, and you do that by adding the molar mass of barium on its own, and then adding sulfur on its own, and then adding 4 oxygens. So you can pause the video and do that using your periodic table. I found to be 233.39 grams of barium sulfate. That is the molar mass. From here, once you multiply this in a calculator, you do this divided by this, and you're going to get a total of 7.113 times 10 to the negative 4th moles of barium sulfate. Good job finding the moles of barium sulfate, but we're not done yet. So, again, since we know 1 mole of our barium halide is going to be equal to 1 mole of barium sulfate in our balanced equation, that means this will be equal to the moles of our barium halide. And we know the amount of grams of our barium halide It's 0.140 of our salt. Barium halide is the same thing as our salt. So let's find the moles of the barium halide. So from here, we remember that it's 0.1480 grams of our barium halide. And from here, we need to find the moles. So we're going to add that to our numerator because we want the bottom to cancel out and to keep the top. And then here is the tricky part. You might be wondering, Amanda, we don't know what the molar mass of this is. How are we supposed to find it? We're going to keep that as a variable. You do know on the periodic table the molar mass of barium. You can pause the video and find it on your periodic table. The answer is 137.33. That is the molar mass of barium. And then you're going to add 2 times the molar mass of your mysterious halide ion. And that's going to be your grams of barium mysterious halide. So that's the grams. You add the molar mass of the barium and the molar mass of your mysterious halide. And then once again, these grams will cancel out and you're going to be left with moles. And that's going to be equal to 0.1480 over 137.33 plus 2x. And that's going to be your moles of the mysterious halide, the mysterious salt. So, you might be wondering, where are we going, Amanda? Well, we're going in a direction. Remember that these two things are going to be equal. So, we're going to set them equal to each other. So we're going to put 0.1480 divided by 137.33 plus 2x. That's our moles of the barium halide, and that's going to be equal to the moles of barium sulfide, which was 7.113 times 10 to the negative 4th. 7.113 times 10 to the negative 4th. So remember, the reason we know that they're equal to each other is from our balanced equation. We know that this is 1 technically, and this is 1 technically, so they're going to be equal. So I can go ahead and set those equal to each other to find the molar mass of our x value here, which will then give us what halide that actually is. Okay? So let's say this is over 1. We're going to cross multiply. We're going to get 0.1480 is equal to 7.113 times 10 to the negative 4th, and we're going to add that in here. Okay? Once we multiply that out, we're going to get 0.1480. You're going to multiply that by this to get 0.098, and then you're going to multiply that by that, and you're going to get 0.0014x. Well, you're going to subtract that over. You're also going to subtract it from that, and you're going to get 0.05 is equal to 0.0014x. We're almost done. We're going to divide both sides by 0.0014. And we're going to get x being equal to 35.376. So what does this tell you? Go to your periodic table with the halide ions. Remember that it's a halide. That means it's going to be in group 17A. which one matches 35.37 roughly? And the answer is Cl. So when you're trying to find what the formula is, remember it was barium, and now Cl, don't forget the 2. And that will be your answer to our problem. Great job, guys. This was a lot of work, but you did it. Or I did it.